Today we will be learning how to calculate amount of heat gained or lost. We know that if we transfer energy into an object, the temperature of that object will increase. And if energy will leave some kind of object or substance, then the temperature of that substance or that object will decrease. So our goal today is learn to calculate how much energy was given to an object or how much energy lost a substance or an object as the temperature changed. Here is our basic principle. If we take some kind of substance and then we transfer energy into it, then the temperature of the substance will increase. But here is an interesting fact. Different substances, compounds, elements react differently to the amount of energy that is transferred into them. If I take 1 gram of liquid water and transfer 4.18 joules of energy in it, the temperature of that water will increase by 1 degree Celsius. If I transfer the same amount of energy into 1 gram of iron, the temperature of the sample will shoot up 9.3 degrees Celsius. And if I transfer the same amount of energy into 1 gram of lead, then the temperature of that sample of lead will shoot up 32.6 degrees Celsius. So different substances respond to transfer of heat in a slightly different way. They have different specific heat capacity or specific heat. It is the amount of energy required to change the temperature of 1 gram of the substance by 1 degree Celsius or 1 degree Kelvin. Look at this table. These numbers represent how much energy it takes to increase 1 gram of that substance by 1 degree Celsius in temperature. Lead or silver have relatively low specific heat capacity. It takes little amount of energy to increase their temperature. But look at liquid water. It takes a lot of energy to increase the temperature of water. When we will be doing our calculations, we will need to take into consideration how quickly a substance will respond to the transfer of energy, how quickly the temperature will be rising. So we need to pay attention to the specific heat capacity of the substance. Another thing that we would need to keep in mind is the change of temperature that we are trying to achieve. If I want to see 1 degree change in temperature for 1 gram of water, I would transfer into it 4.18 joules of energy. That will do the trick. But if I want to be more than that, if I want to see 2 degree Celsius increase in temperature, I would have to transfer the double the amount of energy. And if I need 3 degrees of Celsius, once again I would have to transfer more, 3 times the amount of energy into that 1 gram of water. So the change of temperature that I am trying to achieve will be playing important role in the calculations. And here is the last thing that we need to remember about, the mass of the sample. If I am increasing the temperature of 1 gram of liquid water by 1 degree Celsius, I would have to transfer 4.18 joules of energy in it. But if my sample is bigger, let's say it's 2 grams of water, the amount of energy that I need to transfer into that sample to increase its temperature by 1 degree Celsius would be twice the amount, because I have twice the mass. And if it's 3 grams of water, then 3 times the amount of energy would be needed to achieve that increase in temperature that I am desired to see. So mass of the sample will be playing important role in our calculations as well. Here is the formula that we will be using. The amount of heat lost or gained during the energy transfer depends on 3 things: mass of the sample, specific heat capacity of the substance that we are analyzing, and change in temperature that occurred during that process. Don't forget to keep track of units. The heat is measured in joules. Specific heat capacity is measured in joules per gram per Kelvin or in joules per gram per degree Celsius. Mass is measured in grams, and change in temperature or temperature will be measured in degrees Celsius or in kelvins. Let's go over some practice problems. Here's the first example. 2,000 gram mass of water in a beaker has its temperature raised by 3 degrees Celsius. How much heat has been transferred to the water? Let's see what has been given to us. We know mass, we know change in temperature that was achieved during this process, and specific heat capacity of water can be found in your reference table on the first page. It is 4.18 joules per gram per Celsius. Plug in those numbers into your calculator and see the result. So 25,080 joules is transferred into the water, and that increases the temperature of that sample of water by 3 degrees Celsius. If we want to be true to our idea of significant figures, then the result should be reported as 25,000 joules. How many joules of heat are needed to raise the temperature of 10 grams of aluminum from 22 degrees Celsius to 55 degrees Celsius if the specific heat of aluminum is 0.90 joules per gram per Celsius? Okay, let's see what is given to us. We know the mass of our sample, it is 10 grams, and we know the specific heat of aluminum, 0.90 joules per gram per Celsius, and change in temperature needs to be calculated. The difference between the final and initial temperature will be the change in temperature that we are trying to achieve. Plug in those numbers into your calculator, and the answer is 297 joules of energy are required to raise the temperature of that aluminum sample. And we can use scientific notation to help us to express this number into significant figures. Pause this video right now, solve this problem yourself, and then start it again to see if you have the same answer as me. My answer is 12.3 joules, or I can round it up to 12. Do the same thing. Pause the video and calculate the answer. Please pay attention to units. I hope you remember to convert kilojoules into joules, and this is how we set up this equation. Now we have to solve for mass. The mass of my sample of water comes out to be 54,700 grams. If 418 joules are applied to 20 grams of water, initially at temperature of 20 degrees Celsius, what is the final temperature of the water? In this problem, we are asked to calculate the final temperature of the water. To do that, we need to know how many degrees Celsius was the change in temperature achieved through this process. Let's set up the equation. Now we have to solve this equation for delta T to find out the change in temperature that has been achieved. Change in temperature is equal 5 degrees Celsius. The temperature went up 5 degrees, so we started with 20, increase 5 degrees Celsius, we end up with the final temperature being equal 25 degrees Celsius. Pause this video, solve this problem, and then compare your answer with mine. Okay, my answer is mass of this sample of water is 6.0 grams. Reminder that we know specific heat capacity of liquid water. This is something that is given to us because we actually know water very well, and specific heat capacity of it is known. It is 4.18 joules. This number is given to you in the reference table on the first page. Here is another problem that asks you to calculate the final temperature of the water sample. So please pause this video, solve this problem, and then compare your answer with mine. I expect 10 degrees Celsius change in temperature from this transfer of energy. Since energy was transferred into the water, I expect temperature to rise. Initial temperature was 20 degrees Celsius, so I'm adding 10 degrees Celsius to it. The final temperature of water will be 30 degrees Celsius. And here is a problem that asks us to calculate the specific heat capacity of that substance that is rising in temperature, 38 degrees. We are given mass, we are given change in temperature, we are given how much energy it took to achieve that change in temperature. So we can solve our equation for specific heat capacity. Specific heat capacity of this substance is 2.4 joules per gram per Celsius. And I want you to notice how nicely the units of our numbers end up with the unit of the specific heat capacity. We have joules in the numerator, grams and degrees Celsius into denominator, so our specific heat capacity comes out to be joules per gram per Celsius.